Hi guys, welcome to another concept video from the GMAT guy. This video we're going to start off on geometry. This is the first video for geometry, and in this we will go through all the quick tips and tricks that you need, all the formulae that are the things that I would like you to know before you start doing solving geometry problems, what you would need to know in the topic of triangles. Okay, so this is very important because this is actually a huge chunk of geometry, and this is the most difficult part of geometry. And if you know everything that is there to know about the triangles, rest follows up and becomes easier and easier. Okay, so we're going to go through this really quickly, not a lot, believe you me. Alright, let's get started. So a triangle is basically, it is a polygon, a shape, a closed shape made up of straight lines with three vertices. The three corners are known as the three vertices. Alright, now they're made up of three lines, which are the sides, right? Three sides. Let's call them A. Let's say that one is A units long, one is B units long, and the third one is C units long. And then there are three angles that you can see: X, Y, and Z. Alright, so two quick things to remember about the triangle. First is that X plus Y plus Z is always equal to 180 degrees. So the three angles inside always add up to 180 degrees. If you extend one of these sides, okay, like this, you get an exterior angle over here, and this is 180 minus Y. This is called an exterior angle to the triangle. Okay, so if there are three interior angles, there will be three exterior angles. Every interior angle has one exterior angle complementary to it. So these two guys add up to 180. Okay, so it doesn't matter which side you extend. Even if I extend this side, this angle would still be 180 minus Y. These two angles are known as vertically opposite angles. They are equal to each other. So it doesn't matter which side you extend. Alright. The key thing you have to remember about the three exterior angles is that if you add up the three exterior angles, what do you get? The answer is 360 degrees. Correct. So that's what you got to remember, that when you add up the three exterior angles, so this guy 180 minus X and 180 minus Z and 180 minus Y. So if you add up all these three exterior angles, you get 360 degrees. Okay, good. One more basic thing that you need to know, which is very important for GMAT, and you don't actually study this a lot in school, is that there is something about the three sides, the length of the three sides. Now, the rule is that in a given triangle, no side can be, this rule has to be followed by all the three sides of the triangle, that any given side of a triangle has to be lesser than the sum of the other two sides. Okay, otherwise it will be physically impossible to make the triangle. Okay, now since all three sides have to follow this rule, they have to actually have a minimum as well. And so, just to make it easy for you to remember, any given side of the triangle, let's say A, it has to be less than the sum of the other two sides, and it has to be more than the difference of the other two sides. Okay, now I'm going to put this in absolute value sign. That looks scary. This just means the difference between the two sides. Doesn't matter which one is bigger, B or C. Okay, so any given side has to be more than the difference of the other two sides and less than the sum of the other two sides. Okay, these are two basic things to remember about the triangle. Alright, next thing that in the triangle that you need to remember there are three lines. Now, when you want to calculate the area of a triangle, right, you always take one of the sides as the base. I mean, you place this side, you place the triangle on the ground, and this side, whichever side is facing the ground, is the base. So we call it B. And what you need to calculate the area is the length of the base, as well as how from this ground level, which is highlighted in dark here, from that ground level, how high is the topmost point of the triangle, which is the third vertex or the third corner, and that is your height. And when you have these two, you get half times base times height, and that's the area of the triangle. Okay, so that's the formula for area. If you want to calculate the perimeter of the triangle, then it's just the sum of the three sides, so it's A plus B plus C. Okay, so perimeter is the boundary. Sum of the boundary. Area is what is the area of all this highlighted area. So so it is a two-dimensional quantity, and that's the area, right? Okay, now this length, this height here, this line is the first line that we need to focus on, which is the height. So I'm going to draw another triangle here, quick one. The height is always perpendicular. This perpendicular word, this sign means 90 degrees to the ground, to the base. And this point where the height and the base are meeting does not have to be the midpoint. Okay, so you don't know the ratio of the length of the two sides. You don't know whether these two angles that I'm marking on the screen right now are equal. Nothing of that sort. Height has only one thing. It is perpendicular, so to the base, and it can be used to calculate the area. That's the first line. The second line that you need to know about the triangle is the median. This line also starts from one of the vertex, and this goes to the midpoint of the base of the opposite side. Okay, so this, let's say this is the midpoint. So here what happens is that this side and these two lengths, this entire base, which is, let's say, AB, has been split into half. Okay, so AC is equal to BC. Alright, the length of AC is equal to length of BC. Now this is the median, okay, in the triangle. Remember that one thing about median is that these two angles, it's not an angle bisector, so these two angles are not necessarily equal. We don't know anything. Alright, good. The third line in a triangle is the angle bisector. Great. So that does what we missed out in the last one, which is, if this is the given angle and it starts from this vertex, it basically cuts the angle into half. These two angles are equal. Now it does not matter where it hits the base, so there is no property on that. This is called the angle bisector. Okay, so now these are the three lines that are associated with a triangle that you need to know about. Alright, good. So you know this. Excellent. The next thing that we're going to discuss in triangles is right angle triangles. So in GMAT you'll have a lot of questions on the right angle triangle. Now before I go there, I want to discuss one quick thing. If you have a triangle and let's say this angle here is the largest, which is x, okay, so out of the three angles, let's say x is the largest angle, then opposite x will be the longest side. Alright, so if x is the biggest angle, then a is the biggest side. Alright, so there is a relation like that. It's not mathematical, but at least you can it tells, okay, out of the three angles, if you arrange the three angles in descending order, then their corresponding opposite sides would be also in a descending order of length. Okay, good. Now let's do Pythagoras theorem. Pythagoras theorem is associated with right angle triangles. This is the next thing you need to know when you do geometry, when you prepare geometry triangles. Pythagoras theorem is perhaps the most important thing for GMAT math. Not GMAT math, sorry, pardon me, for GMAT math geometry questions. Okay, what this says is that when a triangle is right angle triangle means that one of the angles is right angle, 90 degrees. Okay, it can't have more than one right angle, okay, because the sum of the three angles is 180, right? So now let's call these two lengths A and B, and opposite 90 is the biggest side, as we just discussed. This is known as the hypotenuse. C is the hypotenuse. Okay, you don't need to know the names and everything, but still, these three sides are associated, like are actually related using this formula. So a square plus b square is equal to c square. This is the Pythagoras theorem. So if you know two of them, you can calculate the third. Okay, just remember that a square plus b square is not equal to a plus b whole square. Okay, so we did this in algebra. I hope you remember it. These two are not equal. If you do, great, move it aside. Okay, so what's the next thing that you need to know? Now, one more thing is, in right angle triangles, calculating the area is really easy, because if b is the base, then a is the height, so you can just calculate the area using half times base times height. Right? One quick thing, one trick I would like to tell you about solving problems in GMAT is that whenever you see a 90 degree, okay, whenever you see two lines which are making 90 degrees like this, you should already know that, okay, you know, what all can I do with this? I can use Pythagoras Theorem, I can calculate area. So there are a lot of applications about the 90 degrees angle, and so that is important. Now, there are some numbers, now these three sides, which is A, B, and C, don't necessarily have to be integers. Fine. But there are some times where this perfect, like when you work with these squares, you get all three integers. Now this happens rarely, and these are known as the Pythagorean triplets, right? So a couple of them just to remember, if they happen to appear in front of you, you can immediately spot them, is the 3, 4, 5. 3 square plus 4 square is 5 square, right? So that is 1. So 3 square plus 4 square is equal to 5 square, right? So if you see 3, 4, you'll already know, okay, third side is 5, and it's a right angle triangle. So there are a couple of things like that you can, conclude. Another one is 5, 12, and 13. I would say just these two, if you remember, is good enough. Rest of the time, rely on the Pythagoras theorem. Okay, right. Now, based on these right angle triangles, since trigonometry is not part of GMAT, there are still two special circumstances where GMAT requires you to remember a bit more. These two special circumstances are: one, when the right angle triangle is isosceles, and now I didn't go into isosceles triangles a lot. Actually, I didn't even discuss it. I'm going to quickly discuss it here. Okay, isosceles triangles. So I'm going to quickly, you don't really need to know these things. I mean, great if you do, if you remember them, but there's nothing much to remember about it. Isosceles triangles basically just means that two sides are equal, and which means the opposite corresponding angles will also have to be equal. Okay, that's an isosceles triangle. Now here, the special thing about isosceles triangle is that when you drop a height right through the middle, cutting it symmetrically between these two equal sides, then this height is not just the height, it is height, it is the median, and it is the angle bisector, which means it bisects the angle, which means these two angles are equal and these two sides are also equal. This happens because of the symmetry, and this happens only in this circumstance. Okay, now how do you apply this in the right angle triangle? Well, when a right angle triangle is isosceles, you got it, the other two angles are 45, 45. Okay, so you've got A, and C. And if you use the Pythagoras theorem, you will notice that the length of these three are in a ratio of 1:1:√2. Root 2 is roughly 1.4. Okay, for estimating when you want to do some quick calculations in your GMAT test, but you don't need to really know much about it. Okay, in GMAT, if you ever are dealing with root 2, you are not expected to know it, so your answer options will be in terms of root 2. Alright, so don't panic. This 1.4 number is just there to make sense of things when you're estimating something, or just to give you an idea of how much the C is, the length of C is in a real sense, okay, as compared to A. Right. Now, another thing is the equilateral triangle. An equilateral triangle, okay, is something special. Now, I can go through I will, might as well. I will go through an equilateral triangle is basically when all three sides are equal, which means 60, 60, 60. You've got 60, 60, and 60 degrees, right? Now what happens here is I'm going to draw another one just without the labeling. Okay, this is also equilateral. Now if I draw a height here, there's something special. Now as we discussed in isosceles, this is a symmetrical cut, so the height is the median and the angle bisector. So we get 30 and we get 60. Notice that there is a special triangle here, the 30, 60, 90 triangle, which you also need to know the special ratios of. Let's say if the side is x, okay, so your this side becomes a, let's say a, so then a over 2, and this side is also a over 2. Okay, let's call it x, just for simplicity's sake, right? The height and the hypotenuse are related. Now I'm going to skip a slight bit of the explanation. I'm just going to straight away get to the formula. Your hypotenuse will be 2x, okay, which is, of course, 2x, because a over 2 is x, which is a, okay, and the height calculated by Pythagoras theorem works out to be x times root 3, okay, and root 3 is roughly 1.7. Alright, so still less than 2. Hypotenuse is still the longest, right? And this is equal to root 3 over 2 times a. Okay, whichever makes it easier for you. I'm going to summarize this in the next slide. So in a 45, 45, 90 triangle, the sides are in the ratio 1, 1, root 2. So if I know any one of these, I can calculate the others. For example, if I tell you this is a right isosceles triangle, okay, and the hypotenuse is 4 root 2, then I immediately, without much calculation, I immediately know the sides are 4, 4. Okay, in a 30, 60, 90 triangle, the same thing works, but with a different ratio. The 30 is always, I always use it as 1. So opposite 30 will be your smallest side. Opposite 60 will be root 3, so times root 3. Okay, so if this is x, opposite 60 will be x root 3. Okay, and 90 would be 2, so 2x. Alright, this is a ratio, very handy. So if you have a 30, 60, 90 triangle, let's say this is 60, this is 30, and we know that, just to give you a quick example, right, opposite 90 is 8. The side is 8. I know that opposite 30 will be 4, and opposite 60 will be 4 root 3. So that's it helps you to speed up your calculations. Alright, so that's pretty much all that you need to know for triangles. Just one last thing is that for equilateral triangle, I forgot to tell you that you can use this height. Since the height is also dependent on the base, the area's formula becomes much easier. Area formula becomes root 3 over 4 times a square. Okay, so I hope that helps. I mean, this is all you need to know for triangles, and you can go ahead and crack all the GMAT problems there is. Alright, see you in the next video for geometry. Thank you for watching. Bye bye.